everyone, welcome to this session. So let's understand what are closures in JavaScript. Alright, so whenever you write function inside function, as in when you write nested functions, that is called a closure, right? So in that case, what happens? The inner function has access to the variable and the scope of the outer function. We also call it lexical scoping, okay? So the advantage of writing a closure is that it allows private variables and state maintenance, alright? So let's check this out with an example. I'm going to write a function. I'll name it as outer function, and then inside this I will declare a variable, let outer variable, and I'll give it a value as I am outside, and then I'm going to define an inner function, and then inside inner function I'm going to log the value of outer variable, and let's run this and see what happens. Okay, so now if I directly call outer function, will it do anything? It won't do anything right now. So if I save this, you see nothing happens because inner function has access to the variable of the outer function, but outer function does not expose the inner function. So basically you can say that the outer function does not have access to the inner function. So for that, what do we have to do is we need to call the inner function inside the outer function. So inner function ends here, right? So I'm going to call this out inner function inside the outer function. Okay, now if I save this, I get the value, right? So just keep in mind that this is how I get the value, right? So this is how we form closure. We write an outer function and then inside that we write an inner function. Now about lexical scoping, what you need to remember is that inner function will have access to the outer function's variable and scoping, but the outer function will not expose inner function, as in it won't have access to the variable of the inner functions. Okay, it won't have access to the inner function at all. So in order to access the inner function, you need to call the inner function in your outer function, and then you can call your outer function normally and then see the values, like see the logic whatever is written in the inner function. All right, so this is point one, as in how you can form closure. Now let's see how does it. So this is how, first of all, this is how it helps in keeping the variables private, right? Now let's see how it is helping in maintaining the state. And also if you want to see that how it is making the keeping the variables as private, what you can do is you can try updating this variable value here, right? So if I do this and let's say I update it to some other value, it won't let me do it, right? See, the value of this variable is still this one, right? The one that we had defined. All right, so it doesn't allow this. Now let's see how it is helping to maintain the state. So I'll create another function and I'll name it as increment, and here I'm going to take a variable for count. We'll initialize it with 0, and then here we are just going to do count plus plus, and then we'll log the value of count. So count, and then let's call this function. So if I call this function, what's gonna happen? The counter variable value will be 1, and if I call this again, the value is still going to be 1, right? So if I keep on calling this, the value is going to be 1 itself, right? But what if I want this? So basically, like if I'm creating a counter, it's not working as expected, right? I wanted it to increment every time. So for that, what can we do is we can either make it global. So let's say if I make it global, what happens now? See, 1 2 3, everything is coming, right? But of course, right, the moment you're making anything global, that means it can be modified from anywhere, right? So now if somebody comes here and then does something like this, count is equals to some value, right? And if I save this, now you see the value of the count got updated, right? So that is why we don't have to lose the privacy of the variable, right? We still want to keep it private. So let's remove this and then let's figure out how we can do it with closure. Okay, so I'm going to keep this here itself. So let me comment all of this and then I'll create another function and then I'll type in outer increment, and inside this function we are going to form a closure. Okay, so to achieve the state maintenance, okay, so in outer function I'm going to declare the variable let count is equals to 0, and then I'll create an inner function. So function and inner increment, and inside this I'm going to do count plus plus, and then I'll log the value of count. And then now if I call this function here, of course nothing will happen because the outer function will not have access to the inner function, right? So we have to call the inner function in the outer function. So here we'll call it, and then now if we see what happens, so see, it's the value is 1, and if I call it again, what will happen? The value will still be 1, right? Because every time you're calling, this particular variable is getting reset, right? It is every time getting reset to 0. So what we can do, we can return here. Okay, so return will return the inner function here. Okay, so let me remove this parenthesis, and then here outside we'll make an instance of, instantiate the outer function. Okay, so I'm going to declare a variable const outer something like that. Okay, outer function, and then here I'm going to instantiate this. So let's just copy this and do this. Now with this variable I can access the inner function, right? So here I'll copy this and then dot inner function. Okay, and now if I let me remove this first. If I save this, we can just call it like this, right? We don't have to do this, and then let me save this. So see, I get the value as 1, and if I call it again now, what will happen? It is not going to reset, right? So if I call it again, you see the value is true because we have already instantiated it once, right? So it is this already got instantiated, right? So every time it is not going to reset the value, right? Here from here we are just returning this. So if you observe, okay, this is one of the examples of lexical scoping, because if you see here this line, right, in this line itself the outer function is getting executed, right? Then how come you are able to access the inner function here? Because even though the outer function is getting executed, even after that the inner function still has the access to the outer function variable and scope as well, right? So this is exactly what happens in closure, and this is exactly what we call lexical scoping, that even if the outer function's execution is completed, right, now this function doesn't have to do anything, the execution is done here itself, but then even after that the inner function still has the access to the outer function's variable and scoping. All right, that is how we are able to call it again and again, and that is how it is helping us to maintain the state of the variable. All right, now let's understand one more thing. So let's say if you have multiple functions here, okay, so if I take this and let me write another function here, and let's say this is not increment but rather decrement, and here I'll do minus minus. So how can I pass multiple functions now? So here, rather than returning a single function, I will return an object. Okay, so here I can include this as well, and then for calling, right, we will use this variable and then dot. If you want to call this one, then you just need to define this one. All right, and if you call, so if I save this, I get the increment value, and if I call it again, right, I should get 2 now. Okay, and if I want to call the decrease one, I can do that as well. So I'll just copy this function now and do this. Okay, so I see the value is getting decreased now. So you can keep on calling any function. So what we are doing here is we are returning rather an object and passing all the functions as property. So let's say if I have another function, okay, so function, I'll say get count val, and here let's only return the value of count. Okay, so if I want the current value of the count, so now let's just pass this function also as a property here. So I'll pass this, and here I will log the value of count, and then I'm going to call the get count val function. So here inside this log, I'll take this and I'm going to call this rather, and here let's just print something. Okay, current count val, and if I save this, you see the current count value is 1. Okay, and here let's say if I so for example, if I keep on increasing it, right, the current value of count will of course get on, like, you know, it will keep on updating. Okay, and it will keep on showing us the current value. Now there's one more thing that I wanted to mention so that you don't get confused, right? So if you observe the pattern here, right, the way these functions have been written and the way we are returning all these functions, right, you know, using object. So what we can do here is, so let's say, let's first comment all these three functions. Okay, and here let me do this. So in object, how do we pass the data? As key value pair, right? So for example, this one, so this is for function 1, and then how do we separate the key and value? By using colon. So I'll use colon, and then which function do I want here? So I want this function, right? So let me first comment it in some different way. Okay, so I'm going to comment it in this way. Now I'll copy function 1. That is what we want inside this property, right? So here this is function 1, and similarly for this function we'll do the same. Okay, so this is only so that you don't get confused, right? That if you see anywhere, like, you know, any closure written, and then if you see, okay, why is it written like this? So rather than doing what we were doing, right, you can directly, like, you know, return the object itself, and then you can define your functions inside. So that's what we are doing here and nothing else. And then similarly, even for this, we'll take the third one and then keep it here. And if I save this, I still get the same result, right? And now we can remove this, and that's it. Let's do one more example and then we can wrap this up. So I'm going to write a function, outer function, and I'll name it as outer function. And inside this outer function, I'm going to declare a variable first. Let score is equals to 0. And then inside this, I'm going to write three functions. Okay, so function increase score, and here I'm going to increment the value of score by plus, like, you know, incrementing it by 1, and then we'll also log the value of score. And then I'm going to write another function to decrement the value, and here I'll write something like this: decrease value and score minus minus, and then we'll get the updated score. So I'll write another function, get updated score, and here we'll just return the value of score. So return 4, and then this is, and over here inside the outer function, okay, we can call all of these multiple functions by returning an object. So return, and then inside this object, increase score, and then decrease score, and then get updated score, right? And then we'll come outside and we will instantiate this outer function. Okay, so const outer something, will give some name, and then we are going to instantiate this, and then using this variable we can can access all the properties of the object. Okay, so increase score, and if I see this now, you see I see the value of the score, and if I do it again, this will get incremented by 1. And if I use the decrease score, right, let me use this one, so this will decrease the score. Okay, if I increment it again, it will keep on increasing, right? It is maintaining the state. And if I use this one, then this will give me the current count of the variable, but we have to console this. Okay, so here log, and then I will just keep it inside the log, current score value. Okay, and here we'll just use this, and I'll save this. All right, and as we discussed in the previous example, what we can do is we can use all these, we can keep all these functions inside here itself. So here I'll just do this, and then let's take this function and we'll keep it here, and then similarly for this one we'll keep it here, right? And that's it. Okay, so I think at least you would have got the basic idea about closures. So all you have to remember is that when you write function inside function, the inner function will have the access to the variable and the scope of the outer function even after the execution of the outer function. Okay, that's what we discussed here, that even the outer function, when it is getting executed, the execution is complete, but the inner functions will still have the access to the outer functions variable and scope. So that is called lexical scoping, and this is how we form a closure, right? And the benefit of using closure is that you can keep your variables private, and you can also maintain state. So that's all about closures, and I'll see you in the next one.